So now in this video we're going to look at using a multimeter to measure current of a circuit. So you notice I say circuit because you do not want to measure the current of a power supply directly. As a general rule, never measure the current of a power source directly, but there are exceptions. There's low power solar cells, very small batteries and stuff that maybe you can briefly measure the current, but for the most part just don't do that. The meter does not limit current. The power source will provide all the current that it can. That may be too much for the meter. It may be too much for the power source. So, in any case, just as a general rule, don't do that. Now, the meter needs to be inserted into the circuit. So that can be along any one of the nodes. So, I opened up where the negative side of the battery is there and the cathode and inserted the meter there. We could also put it where the positive side of the power supply or battery comes to the resistor over there. You can insert that. Doesn't matter. And that's because current flows through equally. So I drew this just kind of as a visualization. There's the same amount of current all the way around. It's moving in one direction. You could also think of electron flows. This is what they used to think, that current flowed from positive to negative. Now we know there's electrons. They go from negative to positive, but the main thing is for the electrons here to move, those also have to move, those also have to move, those also have to move. So along the path they all have to move. It's a circuit. It's a continuous flow. Now we have another option that I really like. If there's a switch in the circuit, you can see how much current is flowing when the switch is closed by just instead connecting the two terminals to the ammeter. The multimeter is set to measure current, and current will flow through the meter just like it flows through the switch when it's closed. The power supply will move the current, and the components will limit the current, whether it's a closed switch or an ammeter in its place. So now really quickly, we're going to take a look at my Lyumi LM2001 because it's not an auto-ranging meter. It has a power button, so you can leave it at settings. I always leave it at voltage when it's off, because if I turn it on and I try to measure the voltage of something, I don't want it to still be on a current setting. It's safer to have it at the voltage setting. But in case we're going to measure an LED, 20 milliamps will probably be perfectly fine right there, but maybe that'll be too low. Maybe we'll bump above 20 milliamps by accident or something. Then you'd want to be at 200 milliamps. We need to move the red probe for this meter to where it says milliamp there. Now, black probe generally stays at COM for all measurements, but this particular meter, you actually have to put it over here when you want to measure capacitance. So that's topics for different videos, but most part COM stays right there for all measurements. Now, if we need to go above 200 milliamps of current with this meter, then you got to go to 20 amps and move the red probe to the 20 amp setting. Now, especially if you're reading like a 10, maybe even 5 amps of current or more, you don't want to take those readings for very long. And especially if you're going to measure like 20 amps, you probably got to take it quickly and then let it cool down for a number of minutes or anything. But in case, we're going to measure milliamps, so there or there. And in fact, I'm going to use a different meter. So since I'm not going to use this one now to measure current, I'm going to get off of measuring current so I don't accidentally measure current the next time I try to measure voltage. So now we got the power supply set to 5 volts for this video. It's off right now. I have to hit the power button to turn the output on. That provides power through the wires there. You can see we got the clips there. Now we got the auto ranging meter. So this one's really simple. All I got to do is set it to voltage. If I want to measure voltage, we can make sure that the power supply rail is getting 5 volts. I set it a tick above 5, and there you can see we're slightly above 5. I have a little orange jumper right there to the rail, and the LED is off because there's no current going through. So it's auto ranging. We just have an amp, milliamp, and microamp setting. So I'll set it to milliamp, and I think this only goes up to like 500 milliamps. I don't think you want to measure maybe even 600 milliamps with it, but there is a milliamp setting. And anything above 500 milliamps, I would definitely just go to the amp range and just get a fraction of an amp. So I'll zoom in, and that's why I grabbed this meter. It's smaller, it fits into the camera a lot better, and we will measure the current. So you got to remember the LED has to be inserted in the right way, and since I'm not getting any current, There you go. I just guess I didn't have a connection. I thought maybe I put the LED in backwards. But there you can see we got about 3 milliamps of current. That's because we got 5 volts, the LED is dropping about 2 volts, and the rest goes across the resistor. It's a 1 kilo ohm resistor, 1000 ohm resistor. If I grab the green LED, it's going to drop a little more voltage. There's going to be less voltage across the resistor. There's going to be less current, but the LED is just naturally brighter. So it's brighter even though there's less current flowing through there, as you can see right there. So having trouble making connections today for some reason. But in any case, we saw that. Now let's put the LED to the negative side of the supply, and the resistor will try not to block the view, but now we'll go up there and you can see the jumper over there. So hopefully we still got a good connection. So I'll put that towards the more negative, that towards the positive, and there we go. We got the LED. Same amount of current even though we're measuring up here. If we put the probes backwards, that's no big deal with these digital meters. They just give you a negative voltage. I believe that they all do. So that was with a 1 kilo ohm resistor, and we will pop that out and grab a 510 ohm resistor and take that same reading. So half the resistance will get twice the current. So you don't really need to take current measurements all that much. Generally calculate the current you're going to get, and you usually get it pretty reliably. So that's with the green LED, twice the current, and we'll get twice the current that we had with the red LED. Pretty straightforward. Again, make sure it's in the right direction. But that's really all there is to measuring current. It's not so bad once you practice a little. And finally we got the switch, which is normally open, but is kind of being rejected by the board today. But it has these pins, which are usually nice to connect even when the rest of the circuitry isn't. So we will pull back. And first we're going to look at how much current the power supply says is passing through when we close the switch. So it's claiming 4 milliamps, which isn't horribly off, but isn't anywhere near as accurate as the multimeter either. So at higher currents it's more accurate. But in any case, we will just complete the path through the switch with the meter right there. You can see we got about 6 milliamps. So that's how much current's flowing when the switch is pressed. So in any case, that's it for this video. Make sure you turn the multimeter off. Definitely get it off of measuring current if it just has a power button. And that's it. Hope you enjoyed. Make sure you check out one of the other videos I'm posting to the screen. Click like, subscribe, the bell, that, donate Patreon if you can. That helps out the most, but just watching videos helps out a ton. Thanks to everybody that does that. I will see you in the next video.